There is a cooling system that costs between $400 and $900 to build yourself and will keep a 1,200 square foot home at 68 degrees Fahrenheit through a southern summer without running a compressor or drawing more than 40 watts from the grid. Once it is in the ground, it runs on the temperature differential between the air and the earth 6 feet down. No refrigerant. No condenser coils on your roof baking in the sun and failing every 7 years. No monthly power bill that doubles in July. In 1881, the ice trade in Boston moved 4 million tons of winter lake ice to warehouses across 3 continents because humans understood that the earth below the frost line stays cold. In 1948, a mechanical engineer named Robert C. Weber in Indianapolis accidentally discovered that his freezer compressor exhaust pipe could heat water, and he reversed the concept to pull heat from the ground. Then someone at a utility boardroom did the math. A $160 billion natural gas heating industry and a $40 billion residential air conditioning equipment market run on the assumption that you cannot control the temperature in your home without buying a furnace and a rooftop condenser and signing a service contract and replacing the refrigerant every 5 years and paying for the electricity to run a 3-ton compressor 12 hours a day in August. A ground source heat exchanger breaks that assumption with a hole and some pipe. This is the story of earth-coupled cooling. The utility industry would prefer you never hear this sentence. Welcome back. Glad you are here. Humans have known that the ground is a thermal battery for at least 3,000 years. In ancient Persia, the yakhchal ice houses used evaporative cooling above ground and earth contact storage below to preserve winter ice through summer in the desert. The structure was a domed mud brick tower with an underground chamber dug 20 feet down where the temperature held near 50 degrees Fahrenheit year-round. In the Cappadocia region of Anatolia, families carved entire homes into volcanic rock, and the interior temperature remained stable within 10 degrees across the year because rock has thermal mass and the earth 6 feet below the surface does not follow the air temperature. In the American Southwest, the ancestral Puebloans built cliff dwellings under rock overhangs and dug kivas partially into the ground. The kiva floor stayed cool in summer. In the 1,800 seconds root cellars across the rural United States were dug 8 to 10 feet down with a dirt floor and stone walls, and they kept potatoes and apples at 45 to 55 degrees through July without any mechanical input. The principle was always the same. The sun heats the surface. Wind and rain and snow move energy in and out of the top few inches of soil. But 6 feet down, the temperature curve flattens. At 10 feet down, in most of the continental United States, the soil temperature is within 5 degrees of the annual average air temperature for that location, and it does not swing more than a few degrees across the entire year. Farmers knew this. They built accordingly. Then, cheap electricity and mass-produced window air conditioners arrived in the 1,950 seconds, and the earth contact method went quiet. In 1852, Lord Kelvin published a paper describing the theoretical reversibility of the refrigeration cycle. He proved mathematically that a device could move heat against a temperature gradient if you supplied work. In 1945, Robert C. Weber was a utility engineer in Indianapolis, and he noticed that the discharge air from his chest freezer was hot. He ran a coil of copper tubing along the outlet and connected it to his home hot water tank. It worked. He then asked the reverse question. If the freezer is rejecting heat, what if I put the cold side in the house and the hot side outside? He prototyped a ground loop heat pump. By 1948, he had a working system pulling heat from his basement soil in winter and rejecting heat into the same soil in summer. The soil acted as an infinite sink because the earth around his house was thermally coupled to a much larger mass that did not change temperature. His system used a compressor and a refrigerant loop like a standard heat pump, but the heat exchange happened underground instead of in the air. The coefficient of performance was dramatically higher because the ground in summer was 60 degrees and the air was 90 degrees. Moving heat from 72-degree indoor air to 60-degree soil takes much less work than moving it to 90-degree air. This is not free energy. This is the second law of thermodynamics working in your favor. Weber shared the design. A few companies built ground source heat pumps in the 1,950 seconds and 1,960 seconds. Then, the natural gas lobby and the air conditioning equipment manufacturers did what they always do. They sold the product that required replacement parts. Before I go further, everything I just shared is barely the surface. I spent months collecting the off-grid heating and cooling techniques the utility industry does not want you to know. Rocket mass heaters, trombe wall retrofits, solar updraft chimneys, batchbox wood gasifiers, evaporative cooling towers, radiant slab systems, thermal mass fireplaces built from salvaged brick. All of it is inside. Vault name. Link in the description. But stay right here, because what comes next is going to make the HVAC industry deeply uncomfortable. The residential air conditioning equipment market in the United States is worth roughly $40 billion a year, according to Department of Energy trade data. The residential natural gas heating market adds another $160 billion. Those numbers depend on selling you a furnace and a rooftop condenser unit that you replace every 12 to 15 years and service every year and feed with grid electricity or natural gas every month. A ground source heat exchanger threatens that model because once the loop is in the ground, it does not wear out. HDPE pipe rated for ground contact has a functional lifespan over 50 years. There is no outdoor condenser coil to corrode. There is no air filter to sell you. The system is a closed loop. You can run it with a small circulation pump that draws 40 watts. If you add a heat pump compressor to actively move heat, the system still uses 70% less electricity than a conventional air conditioner because the earth is doing most of the work. But the industry does not sell ground source systems to residential customers at scale. The equipment manufacturers produce them. Installers are certified to install them, but the market share is under 2% of new home construction. Why? The upfront cost. A professional geothermal heat pump installation with a drilled vertical loop field costs $15,000 to $25,000. A conventional HVAC system costs $6,000 to $10,000. The financing model in American home construction is built around minimizing the builder's upfront cost and passing the operating cost to the homeowner. The builder installs the cheapest system that meets code. The homeowner pays the power bill for 30 years. The utility collects the revenue. The ground source system saves the homeowner thousands of dollars over a decade, but the builder will not pay the extra $10,000 upfront unless the buyer demands it, and most buyers do not know the option exists. This is not a conspiracy. This is a market structure that rewards the wrong incentive. In 1978, the federal government briefly recognized this and passed tax credits for ground source heat pumps as part of the post-OPEC energy policy. Adoption increased. Then in 1986, oil prices collapsed and the Reagan administration let the credits expire. Installation rates dropped by 60% within 2 years. The HVAC industry went back to selling rooftop condensers. Here is the version that costs $400 to $900 and you can build it in 2 weekends. This is not a heat pump. This is a passive earth-coupled heat exchanger. It will not replace a 3-ton air conditioner in Phoenix in July, but it will cut your cooling load in half, and in moderate climates, it will eliminate the need for mechanical cooling entirely. Step 1. Dig a trench 100 feet long, 6 feet deep, 18 inches wide. If your property does not allow a straight trench, you can loop it or run 2 parallel trenches 50 feet each. The critical number is 6 feet of depth. Above that, the soil temperature swings with the season. Below 6 feet, you hit the stable thermal zone. In most of the continental US, that temperature is 50 to 60 degrees Fahrenheit year-round. Step 2. Purchase 200 feet of 3/4-inch nominal diameter HDPE pipe, high-density polyethylene rated for potable water or ground contact. This costs roughly $1 per foot at a farm supply or irrigation store. Total cost $200. Step 3. Lay the pipe in the trench in a continuous run. You can coil it loosely or lay it straight with elbows. The goal is maximum surface contact between the pipe exterior and the soil. Do not use PVC. PVC cracks underground over time. HDPE flexes. Step 4. Backfill the trench with the native soil. Tamp it down in 6-inch layers to ensure contact. No air gaps. Let it settle for 1 week. Step 5. At one end of the pipe, run it into your home through the crawl space or basement wall. At the other end, install an intake vent at ground level with a coarse screen to keep out rodents. Inside the home, connect the pipe outlet to a simple manifold box. Mount a 12-volt DC brushless fan at the outlet. Salvage this from an old computer power supply or buy one for $15. Wire it to a 12-volt DC power supply or a small solar panel. The fan draws 10 to 20 watts. Step 6. In summer mode, the system works as follows. Outdoor air enters the intake vent. It travels through 100 feet of pipe buried in 60-degree soil. The air temperature drops toward the soil temperature. By the time it exits into your home, the air is 15 to 25 degrees cooler than the outdoor ambient. The fan moves the air. You are not compressing refrigerant. You are not running a compressor. You are using the thermal mass of the earth to pre-cool ventilation air. Step 7. In winter mode, reverse the flow or simply use the system as tempered fresh air intake. Air entering at 30 degrees, Fahrenheit exits at 50 degrees. Your heating system only has to lift the temperature from 50 to 70 instead of 30 to 70. This cuts your heating load by 40%. Total material cost breakdown. 200 feet HDPE pipe $200. 12-volt DC fan $15. Pipe fittings and manifold box $40. Intake vent screen $12. Miscellaneous hardware $20. Total $287. Add the cost of your labor digging the trench or hire a local excavator with a trencher for $300 to $500. Total project cost $400 to $900 depending on whether you dig by hand or hire equipment. Build time 1 weekend to dig and lay pipe, 1 day to connect and test. Observable confirmation. Place a thermometer at the intake vent and another at the outlet inside the home. Run the fan on a 90-degree afternoon. Within 30 minutes, the outlet air temperature should read 65 to 70 degrees. You have just demonstrated earth-coupled cooling. 2 real use cases. For a 1,200 square foot home in a temperate climate like Tennessee or North Carolina, this system provides enough cool air during the day to eliminate the need for air conditioning if you also use ceiling fans and close windows during peak heat. For a workshop or garage in a hot climate like Texas, this system will maintain interior temperatures 15 degrees below outdoor ambient, which makes the space usable in summer without a compressor-based air conditioner. One honest limitation: this system depends on soil moisture content. Dry sandy soil has lower thermal conductivity than moist clay or loam. If your soil is dry sand, the temperature drop will be smaller. You can improve performance by watering the soil above the pipe trench during dry periods or by adding a layer of bentonite clay around the pipe during installation. Bentonite costs roughly $12 per 50-pound bag and improves thermal coupling. Another limitation: the system provides ventilation cooling, not recirculation cooling. It works best when you are bringing in outside air. If you want to recirculate indoor air through the ground loop, you need a closed-loop system where the air never leaves the pipe and you use a heat exchanger. That build costs more, but it is still under $2,000 with salvaged components. Roman engineers understood thermal mass. Korean builders understood underfloor heat channels coupled to the earth. Weber in 1948 proved the heat pump could run backward and forward using the ground as the exchange medium. $40 billion of air conditioning equipment sales every year depend on you not knowing that the earth 6 feet below your house is already doing the work of a condenser coil for free. You can access that with a trench and some pipe and a fan. Subscribe if you want the next one. Share this if you know someone paying $200 a month to cool a house in summer. The next time we open the vault, we are looking at the $400 sand battery that holds heat for 3 days and replaced a $1,500 propane bill. Thank you for being here.